right. Cool. I think we're about ready to get started here. Hello, everyone. My name is Matt Fuad. I'm the product manager for AR and VR at Unity. I also have one of our lead engineers here, Mike Durand. He's one of our lead engineers on our XR team. First of all, congratulations for being here. Day 3 of Unite Copenhagen. Appreciate you guys not making me look bad by filling in the seats here. Today's talk is going to be about just our general Unity's XR platform and how we support all of the AR and VR platforms that we do today. Just want to give a quick lightning overview of a new architecture that we've been shifting to and have built in the past year or two. And hopefully it'll be informative. We'll go a little bit into the technical weeds, but we'll also look at how that impacts your workflow and really making that seamless for you guys to really focus on creating experiences and not have to worry about platform specifics. So just a quick primer on different topics we'll go through here. We'll go through a timeline of Unity and how we've supported AR and VR about 5 years ago. And then we'll cover a little bit of learnings that we've aggregated over the years, how we've taken those learnings and improved the way we want to support the ecosystem with this new architecture, and then again, how that actually impacts your guys' workflows. And just a quick show of hands, who here currently develops for AR and VR or is intending to? Okay, cool. You're in the right place. So as you guys know, today Unity does support all major AR and VR platforms. It's a big reason why XR developers choose to use Unity, and we want to maintain that. We want to double down on our investment of build once, deploy anywhere, being able to reach all the devices that folks are interested in deploying to. And so let's go through how things started and what's changed along the way. So back in 2014, about 5 years ago, we started working with Oculus on supporting the Rift as well as Gear VR. And then around the same time, we also started working with Microsoft on supporting the HoloLens. And by 2015, we were able to land support for Oculus, as well as the HoloLens, and then PSVR. And that was this notion of one-click integration. You click Enable VR, you create your experience, and boom, you're ready to go. So that was really cool. However, these were all direct platform implementations into the Unity engine. And this created, it created just sort of any bug fixes that needed to be made only affected platforms themselves. So it got us thinking to, how can we improve the way we support these platforms in a much more seamless way? So in 2016, we added support for Google Daydream and Cardboard. And that's also when we added a shared implementation where now any bug fixes that we make, we're able to be applied across platforms rather than just one itself. So it really allowed us to be a little more flexible in that way. In 2017, Apple and Google released ARKit and ARCore, which made a big splash in the augmented reality community. Soon after that, Unity built plugins that supported ARKit and ARCore on Bitbucket and GitHub, respectively. But we always dreamed of unifying support for multiple platforms, and that's when AR Foundation made its initial release about a year later. And so part of that was this new plugin architecture that we'll go to in a couple minutes here. But that's really what started kicking off this work. So like I said, about a year later is when our first release of AR Foundation came out. And that was really the first user of this new plugin architecture that the team has built. Alongside that, we also landed Magic Leap support. And then we also created an abstraction for VR in terms of display, as that was, that's a common piece of functionality across all these devices. And in 2019, that's not a logo there. That's actually supposed to represent packages. But we took the plugin, this new plugin architecture, and we were able to migrate all of our platform implementations now to packages, which creates a huge amount of flexibility. And we'll go into the benefits of that and how we feel it's going to make a pretty big difference for users. So just a quick snapshot. It's kind of crazy to think about how the industry and ecosystem has changed over the 5 years. There's a lot of good that's happened, but we know there's a lot of work and a lot of opportunity for Unity as a platform to make things more scalable, flexible, and really alleviate as much pain for our developers and our community. So now we're based on that timeline and along the way, just a couple quick points about what we've learned and our plans to improve on that. First, we're going to continue seeing this trend of new devices entering the market, released from multiple vendors. It's crazy to see how much has changed in the past 5 years, and we believe that we'll continue to see this trend on in the next 5. So we'll continue to see new platforms and new devices enter the market, released by different vendors. Alongside that, we're going to see a whole swath of new AR and VR features. For augmented reality specifically, you see that with AR Kit and AR Core, just really exciting new tech. And these features are now being released at a much accelerated pace as well. So part of that problem is for Unity is how do we provide the community access to those features as quickly as possible and sort of reduce that latency there. Given the amount of new features, though, what we've noticed is that there is a common set of functionality across devices, and that's including both AR and VR devices. So part of this new plugin architecture that we've created is recognizing that there is sort of this bucket of lowest common denominator where we can abstract some of those common pieces of functionality. And that leads into how we plan to improve on that. So the plugin architecture is a set of standard set of APIs designed to improve the developer community's access to not only the devices themselves, but also the features that are continuously being released by these platforms. So we believe this is going to make it easier for developers to access our device integrations into Unity, as well as again, being able to implement various common features across all of these devices. So we also want to really lean on our principle of build once, deploy anywhere. So part of this architecture includes a developer layer where we recommend developers digging into those APIs. And the clear example of that is what you see with AR Foundation. So AR Foundation sits on top of this architecture, but it's really a single framework that wraps around all the platforms that we support. And it's designed to be extensible so we can add new platforms and devices as they come to market. And then lastly, flexibility with packages is going to be a big thing. Being able to have access to new features and devices outside of Unity's release cycle where you don't necessarily need a custom version of Unity is going to be huge. In 19.2, we landed all of our officially supported platforms and migrated them as packages, and it's actually going to be landing in a verified state in 19.3. So we're excited about it. It's still sort of an early development stage. We want you guys to try it out and give us feedback on how it's been for you. But we think with Package Manager, it's going to really increase the amount of flexibility in getting access to these devices and features. So let's go in a bit to what this architecture actually is. It really just provides native API to third-party providers, whether you're an HMD manufacturer, whether you're a runtime SDK like ARKit and AR Core, and exposes that to a higher level managed C# API for developers to work off of. The way this works is there's multiple backend plugins. We term that as providers, third-party providers, that then implement individual engine features, we term that as subsystems, and we'll go into what that actually means in the next slide here. Exposed as common developer-facing C# APIs. This is runtime discoverable as well as runtime activated. And there's this notion of common lifecycle across all subsystems and providers, just using those two terms there. And then we've also looked at how this enables backwards compatibility as well. So digging a little bit into subsystems here, really just a term to describe a common piece of functionality across whether hardware or software. Examples of this include display, rendering. If you're looking at augmented reality, it's things like plane detection, face tracking, image tracking, object tracking. These are all features that we're starting to see being released by several providers, especially in the augmented reality space. But the same sort of applies for VR devices as well. So this notion of subsystems fundamentally improves how we deliver and manage SDKs for all of our AR and VR platform integrations. Subsystems and the APIs that developers use to interact with them are designed to be completely independent from one another. So let me just give you an example of this. Let's say you're writing an augmented reality experience, and you want that experience to prioritize or prefer 3D object recognition. However, the experience can also use 2D image recognition at the same time. What you can do is you can use your cross-platform code to query the object tracking subsystem, and if the device, if that subsystem is available based on the end user's device, it'll trigger a certain behavior based on the object recognition. However, if the end user's device doesn't, if the platform doesn't have the object tracking subsystem, then the application code can just fall back on 2D image recognition. So you could set that all up in your application code, and none of that code needs to know about any specific platform within this architecture. The code just simply queries the subsystem itself based on the availability of that particular feature. Another scenario where, to sort of exemplify this is, you might have two platforms that both provide plane detection and tracking, where one platform only detects horizontal planes, but another platform is able to detect both horizontal and vertical. So minor differences in capability like this can actually be expressed via metadata called a subsystem descriptor. So in this example, a read-only C# property expresses the underlying platform's capabilities, but still does so in a functionality focused manner rather than in a platform-specific manner. So again, being able to abstract in a platform-agnostic way within the application code for developers is the key difference here. So now let's sort of break it down a bit deeper. So each subsystem contains a developer-facing C# interface, a native interface, which is then implemented by multiple backend providers via dynamic libraries, and then sort of this interface layer where you've got common engine code, which handles communicating between the C# interface and the rest of the implementations by the providers, and then the rest of the engine. What does this look like sort of visually? And I know this is a lot, but we'll take it step by step here. On the left, you've got what we're calling the provider framework. And this layer defines the implementation of the platform and the device-specific SDKs written against predefined subsystem interfaces that then connect to the middle layer here that's titled Unity XR Platform, and that's essentially the abstraction or the what we call the interface layer. The provider framework on the left also handles the translation of platform-specific representations into platform-agnostic subsystem data. So moving on to the interface layer in the middle, this layer contains the optimized core engine implementation that will then execute the provider code written against those predefined subsystem interfaces. It's also good to note that the subsystem APIs purely provide data and not game objects. And that's where we get into the right side here, which we're calling the developer framework, otherwise commonly known as AR Foundation, as the concrete example there. So this is the layer that exposes the functionality of the subsystems in a developer-friendly way, which then includes the game object-based representations of the data we get from the APIs. Again, these are the public APIs that we encourage developers to code against. So that's really, that's the area that you focus on, and then everything to the left just gets handled automatically. Here's a view of all of the supported subsystems to date. We've got camera, depth, display. We've got a whole suite of augmented reality features that are pretty commonly found in AR Foundation. Things like face tracking, image tracking, object tracking, environment probes. For the wearables, you've got things like gestures. This is for all of you that have developed for AR and VR. These are common features that you guys are familiar with. But this is sort of the tangible view of what subsystems are and how we view these common pieces of functionality and sort of group them together in a platform agnostic way. Okay, so that's pretty much an overview of what this new architecture is, sort of the benefits you get from it, how we believe it'll improve Unity as a whole, and how we support platforms, but also how we funnel all of that into a developer-friendly way. But what does this actually mean to you, and how can you start digging into this and really get started? So all of our officially supported platforms have now been migrated as packages. And what that means is all of our provider releases are now decoupled from the core Unity engine releases, which is really cool. There's also this new entry point that we've created, and that's what we're calling the XR plugin management package. So one of the problems with this is, okay, there's still this huge swath of platforms that I want to build for. How do we preserve, that reduced fragmentation, making that as seamless as possible? So this is our first step into that. It's called XR Plugin Management. It's available on the package manager in preview. And what that looks like in the editor, you start. So one of the big differences, compared to the current workflow, you're actually going to go into your project settings instead of you're going to your player settings as a first step. Sorry, I got that flipped. Instead of going to player settings, you're going to now go into your project settings. But before that, again, you'll need to go into Package Manager. You'll download the XR Plugin Management package, which will then bring this up. You'll see on the bottom left there the XR Plugin Management setting. So now this is going to serve as your main entry point for both loading the right package for each of your target SDKs and platforms, as well as managing the respective settings for the devices that you're deploying to. So again, XR management, once you've downloaded it, this will pop up. You do need the XR plugin management for this to work. Once you download that, it'll take you to this. And again, this is where you'll be able to both load and manage your SDKs, and you could sort of see the first step into what that workflow looks like. So we know that we're still early in this process. This is the first step. We've now taken all of our officially supported platforms, migrated them as packages. We did that in 19.2 a couple months back in preview. They're expected to land in a verified state in 19.3. So we highly encourage you to check this out. There's actually a thread on the forums called XR Plugin and Subsystems, where it's got a link to a survey. We'd love to hear your feedback. We do want to make sure that the user experience for managing all the platforms that you want to target is done in a seamless way. We want to make sure that we're doing the right thing, making the right design choices, and making that process as easy as possible. So back to what this looks like. We're currently actively in the process of seeing any improvements that we can make to this. I'm happy to meet with any of you guys if you want after this presentation, have those conversations, and at the same time, we're going back to the drawing board and seeing what we can do to improve that UX experience based on this single entry point. And that's pretty much it. That's a lightning overview of the new architecture that we're building. We're super excited about it. We hope you are too. We just want to say thank you for continuing to use Unity to build all of your exciting AR and VR experiences. It's going to be an exciting next 5 years based on the past 5. Mike and I will be on the side here. If you guys have any questions, feel free to meet us, say hi, introduce yourselves. But other than that, thank you for joining, and hope you have a great rest of the week on the final day of Unite. Thanks, everyone.